Okay, we're on Lesson 3, Module 1, Statistical Sampling. Sampling is the process that we use to select a subset of the larger population. It's very practical and useful because, as we've talked about, it would take a lot of time, a lot of money, and a lot of effort to study the entire population. Although the government does try to do this every 10 years, it's called the census. The sample is examined, information is interpreted, and it's applied back to the entire population. For example, in a presidential election, opinion polls, samples of 1,000 to 2,000 people are taken. The opinion poll is supposed to represent the view of the people in the entire country, and then the media and various research organizations use that to predict who they think is going to win the election. You must be very careful when you're choosing a sample because you want to make sure that your population is well represented so that the results of your study will be meaningful and useful. When thinking about a sample, all samples should be representative, which means your sample, your small group, must have the same relevant characteristics as the defined population or the big picture focus. And the sample doesn't favor one group of the population over another. The sample should also be random. The participants should be selected by chance. There's really no rhyme or reason to their selection. In this lesson, we're going to look at and identify 5 sampling techniques that can help to ensure the randomness and the representativeness of the sample. They are random, systematic, convenience, stratified, and cluster. And we're going to view these as individual sampling techniques. However, in most research studies, researchers would use a combination of 2 or more of these techniques. So the first one is random, sometimes called a simple random sample. Each sample has the same size, has an equal opportunity of being chosen. Initially, each member of the population has an equal chance of being selected for the sample. A good example of a random sample is drawing names from a hat. Everybody's name is put into the hat and mixed up, and then one is drawn out. Any sort of random number generator, similar to what's used for drawing the lottery numbers. Second is systematic. With systematic sampling, you select a random starting point and then select every nth subject in the population. You always want to look for that nth, that word. This particular technique is very simple, and so it is used quite often. Convenient sampling is where you use results or participants that you have easy access to. Perhaps family members, students in a classroom, mall shoppers. Probably all of you at one time or another have seen someone with a clipboard in the mall trying to stop people to ask them questions. You have to be careful with convenience sampling because it might result in a non-representative or a biased sample. Fourth is stratified. With stratified sampling, your population is divided into at least 2 groups called strata, and based on some characteristic, whether that be gender or age, location, whatever, and then you draw some subjects from each group. So we might divide the population into male and female, and then we choose some males and some females. This allows us to create a more representative sample that has similar makeup to the population. It also helps to preserve certain characteristics of the population. Fifth is cluster sampling. With cluster sampling, the population is again divided into groups called clusters, but this time we randomly select a group and we survey or collect data from all the members of a particular group. So with cluster, we have groups, but we survey all of the group. This particular sampling method is used extensively by government and research organizations. So, and again, an example would be something similar to an exit poll. Let's take a look at some examples. Scenario number 1 says, a study is done to determine the average tuition that San Jose State undergraduate students pay per semester. Each student in the following samples is asked how much tuition he or she paid for the fall semester. So researcher number 1 collects a sample of 100 undergraduate San Jose students by organizing the names by classification, freshman, sophomore, junior, senior, and then selecting 25 students from each classification. I think groups, and then I select 25 or some from each group. So I think that is stratified. Researcher number 2 uses a random number generator to select a student from the alphabetical listing of all undergraduate students in fall semester. Starting with that student, every 50th student is chosen until 75 are included in the sample. 50th, that TH word jumps out at me, which would be systematic. Same scenario, researcher 3 uses a completely random method to select 75 students. Each undergraduate student in the fall semester has the same probability of being chosen at any stage of the process. It's identified almost basically in the problem that we're doing random. Fourth researcher, the freshman, sophomore, junior, and senior years are numbered 1, 2, 3, 4, respectively. A random number generator is used to pick 2 of these years. All students in those 2 years are in the sample. I notice I have groups, and I'm going to talk to all students in 2 of the groups. That's cluster. Finally, an administrative assistant is asked to stand in front of the library one Wednesday and to ask the first 100 undergraduate students he encounters what they paid for tuition the fall semester. Those 100 students are the sample. That's obviously convenience because I have easy access to the folks going into the library. Scenario 2. Soccer coach selects 6 players from a group of boys aged 8 to 10, 7 players from a group of boys aged 11 to 12, and 3 players from a group of boys aged 13 to 14 to form a recreational soccer team. Again, I think about groups and some from each group, so that's stratified. Scenario 3. A pollster interviews all human resource personnel in 5 different high-tech companies. I've got 5 different high-tech companies or groups, and we're going to do all the human resource personnel. That's cluster. Scenario 4. A high school educational researcher interviews 50 high school female teachers and 50 high school male teachers. Again, I got 50 and 50 sorted by gender. I'm thinking groups, some stratified. Scenario 5. A medical researcher interviews every 3rd cancer patient from a list of cancer patients at a local hospital. I have 3rd, so that's systematic. Scenario 6. A high school counselor uses a computer to generate 50 random numbers and then picks students whose names correspond to the numbers. That's random, using a random number generator. And scenario 6. A student interviews classmates in his algebra class to determine how many pairs of jeans a student owns on the average. Using classmates, that's convenience.